Hello, welcome to today's lesson on section 5.5, which is about the remainder and factor theorems. Before I talk about these theorems, there are a couple examples I'd like to talk about. So we've done adding, subtracting, and multiplying of polynomials. We've yet to do division. So what if you had this? What if you're asked to divide the following? Divide x cubed plus 5x squared minus 7x plus 2 by x minus 2. There's two ways you can do this. Long division, which you might remember from a few years ago. I think maybe you guys did in 3rd or 4th grade. And synthetic division, which is very similar to the synthetic substitution that we did last week. So let's start with long division, just so you see how that looks. So if you remember from back in the day, you have a little symbol like that we call it the radicand. X cubed plus 5x squared minus 7x plus 2. You have x minus 2 on the outside. Then what you want to do is you want to ask yourself the following. What times x gets you x cubed? Because I want to focus on this and this here. So what times x gets you x cubed? Well, that would be x squared, right? So you multiply it, you get x cubed minus 2x squared. And what we're probably going to do is, off to the side here, and I probably actually should have done this earlier, I just realized it right now. What if I asked you to do, let's see here, go green. 453 divided by 6. You do something like this. You figure 6 goes in 45 7 times. Then you multiply 6 and 7 to get 42. Then you subtract, bring it down, then you kind of repeat the process. How many times 6 goes in 33? 5 times 30, 3, so the remainder is 3. Well, we're going to kind of do the same thing for this process. So I figured x goes in x cubed, x squared times. Then multiply x minus 2 by x squared to get that. Then when I subtract, be careful. Those go away. That becomes 7x squared minus 7x. Now what times x gets me 7x squared? 7x. So you work that out. So you get 7x squared minus 14x. 7x squareds go away. You get 7x plus 2. Then what times x gets me 7x? 7. Because x goes in 7x 7 times. Work that out. You get 7x minus 14. You get 16. And what we say when we have a remainder, we'll say plus 16 over x minus 2. Because if you think about it, when you have 75 remainder 3, it's actually 75 plus 3, 6, or 75.5 for this problem. If you actually work on the calculator, that's what you would get. So that's what we have here. You may not be a fan of this method, so let's try synthetic division. I think that one's a little bit cooler. So for synthetic division, here's what you do. You draw that half box or whatever you want to call it. Put in your coefficients. So 1, 5, -7 and 2. And then you put a 2 out here. You're assuming that x minus 2 is a factor of the polynomial. So we take the 0 of x minus 2, which is just 2, because the 0 is when you set equal to 0 and solve for x. So bring the 1 down, multiply, add, multiply, add, multiply, add. What does these represent? The coefficients. And because you start with x cubed, we know that this is going to be the coefficient for x squared, because you want to go 1 down. 7x plus 7, and your remainder is 16, and you do it over x minus 2. So synthetic division could be a really good way to go. Let's talk about remainder and factor theorem. So let me type these up, then do a couple examples, and the video will be done. So let me find a place where I can type some text. Remainder theorem. If a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. And I'll explain what that means in a little while. The other one will be the factor theorem. And what that states is that a polynomial f of x has a factor x minus k if and only if f of k equals 0. Okay, so let's do two examples that kind of deal with that. So let's say you're told the following. Factor 3x cubed minus 4x squared minus 28x minus 16 if x plus 2 is a factor. So basically we're going to be using, in a way, the factor theorem. The remainder theorem actually we just did. Because if you were to plug in 2 for the first one here, if you plug in 2 into this and call that f of x, it would equal 16. So we actually already kind of taken care of the remainder theorem, because the remainder is what f of 2 would be, or if you plug in 2 for x into that polynomial. But in this case, we know that x plus 2 is a factor, so it means we expect, let's go darker. We expect remainder to be 0 because it goes in cleanly. So if you work it out, bring it down, multiply, add, and multiply, you get 0. So it's 3x squared minus 10x minus 8. Then we can factor this, doing the diamond. That would be negative 12 and 2. And actually I kind of did that prematurely, because I have to split the middle term. So 3x squared minus 12x plus 2x minus 8. You can factor out 3x. So you have x minus 4. Factor out 2. You have x minus 4. And if we think about it, x minus 4 times 3x plus 2. So the factor form of this would be x plus 2 from earlier, x minus 4 times 3x plus 2. Okay, and the last one, number 4. What if you had this? 1, 0, of f of x equals x cubed minus 2x squared minus 23x plus 60 is x equals 3. Find the other zeros. So that means that we expect the remainder to be 0. So if I put 3 out here, 1, negative 2, negative 23, and 60, and work it out, bring the 1 down, multiply, add, multiply, add, multiply, add. So we do expect 0 there. So it'll be x squared plus x minus 20 equals 0. Factor, it should be pretty easy to factor. 5 and negative 4. See x plus 5, x minus 4. So your other zeros will be negative 5 and 4. And that's it. So I'm done with the video for 5.6. Sorry, 5.5. And I'll see you guys next time in class. Goodbye.